So today we're going to be learning how to find the greatest common divisor of all three numbers, 16, 24, and 36. I started off by writing out all the factors of each number so that we have more time to talk about it. So first of all, we're going to look at the largest number, which is 36. We know that there's no number greater than 16 here, since 16 is our number. So any number greater than that is not going to be used, as well as 18 and 24. Then we start to look at 16, and we notice that there's not a 16 that occurs in all three numbers, so we know that that number can't be used. We look at the 12, and we see that 12 occurs in 36 and 24, but it does not occur in 16, so we also have to cancel that out. Next, we look at the 9. We know that there's a 9 in 36, but it doesn't occur anywhere else. It's knocked out. We look at the 8. We know that there's an 8 in 24, 8 in 16, but it's not in 36, so we also have to cancel that one out. Then we look at the 6, and we notice that 6 occurs in 36 and 24, but not in 16. Also, not able to use. Then we look at the 4. We see that a 4 occurs in 36, 24, and 16, and we can stop right there since that is the greatest number, since we're starting with greater numbers first, that can easily be a factor of all three numbers. So now we're going to be learning how to find the greatest common divisor of 16, 24, and 36 using a different method, the factor trees. So first off, I'll start with 16, and we're going to find out two numbers that multiply to 16, which I'm going to use 8 and 2. Now I'm going to stop here at 2 because 2 is prime and we can't divide it any further besides using 2 and 1, which are both prime already. So we'll stop there. And then 8 can factor out again to 4 and 2. We'll stop right there at 2. And then 4 can factor out again to 2 and 2. So these are the factors of 16 in a factor tree method. Now we'll move to 24. We know that 24 could be 8 times 3. We know that 3 can't factor out any further. 8 goes into 4 and 2. 2 can't factor out any further. And then we're left with 2 times 2. And those can't factor out any further. 36, we're going to go ahead and use 9 times 4. So the 4 can factor out to 2 and 2. And then they stop right there. 3 can factor out to 3 and 3, and we'll stop right there. Our next step now is to find out a greatest common divisor of all of them, so we'll start with the greatest number, which is 3. So we see 3 occurs here in 36, it occurs in 24, but it does not occur in 16. So we know that all 3's cannot be used. We'll move on to the next number, which is 2. We see that there is a 2 here, a 2 here, and at least 1 2 here. So there's at least 1 2 in each number. We'll go ahead and write that down on the side and circle a 2 from each one, knowing that we have taken one of those out. Then we look and see, are there any more 2's that we can take out? We look at 36, yes, we can take one more. We can take one more in 24, and we can definitely take one more in 16. So let's go ahead and take that one out, and then write it here to use later. And then we're going to check one more time. There are leftover 2's here, 2 more of them, 1 more here, but there are none left here. So we know that that is where we're going to stop. So our final step is to multiply whatever's left here, which is equal to 4. So you know that your greatest common divisor in all three numbers is 4. So now we're going to find the greatest common divisor of 16, 24, and 36 using the ladder method. So the first step is to write out all three numbers side by side and go ahead and draw an upside down dividing sign. And since all three numbers are even, we know that we can divide a 2 into those numbers. So let's go ahead and put the 2 on the outside, and just like a regular division, you're going to put the answer right underneath the number. So how many times can 2 go into 16? 8 times. Move on to the next number. How many times can 2 go into 24? 12. And how many times can 2 go into 36? 18. Now we see that these numbers are still even, so we know that we can divide it further. So let's go ahead and divide it by another 2. So 2 goes into 8 4 times, 2 goes into 12 6 times, and 2 goes into 18 9 times. Now, not all of these numbers are even, and we know that there's nothing else we can divide them by. So we're left with 1, 2 that can go in all numbers, and another 2 that can go in all numbers. And we're going to go ahead and multiply those together to get the common divisor of 4.